I would like to acknowledge my co-authors, Cheryl Ryan and Andrew Morn from the Department of Water and Environmental Regulation. And I also had two people check that what I'm saying is not completely wrong, and that was Phil Commander and Peter de Brock had a look through and made sure that it would pass some muster. Okay, so it has had some review. This is the area that Peter Cassetta was showing you earlier on, with the Landsat imagery going up north of the Stirling. So you've seen this image before, and what we're going to do in this talk is to drill down and have a look what's in these paleochannels and what we know about them. And some of this has come through, particularly the eastern ones from Rockwater, and all of the data that I've got up here will be acknowledged as where it's come from. But as Phil has said, you know, the original paleo drainages were east to west because there wasn't a southern ocean, and obviously the modern drainages have now cut through from north to south, but the deeper drainages are very deep, so they're not. One's going at great depth. You know, the paleochannel drainages are quite deep, and the other ones are just cutting in from the top. So they're I guess there was a question on the bus as to how do they interact, and I don't think anyone's really looked at that. So if you know the Calgan River, if you like, goes over one of the many peaks paleo drainages, no one's really studied that I'm aware of. Maybe Rockwater has, as what the interaction is between those two. So the paleo drainages, they really are important because if we didn't have the one here, particularly in Albany, we wouldn't have a good water supply, because the surface water provision here in Albany is very poor. And in fact, in those drought years, I believe there was no water coming out, significant water coming out for drinking water from the surface water. So it's 2.1 gigalitres comes out, and it goes to this lower Greater Southern Towns water supply scheme, which is connecting up a number of the towns on the south coast here. And increasingly now that system is, so that's about half the water, if you like, is coming out of this system. And as you know, that the Water Corporation have now connected up a pipe from the Albany, or the lower Greater Southern Towns, is going out to Denmark as well. Also, some of the smaller towns have actually supplied by carting. So there's, if you go out to Wellstead, you'll see a big tank there, and I believe it's being carted out from this lower Great Southern Towns water supply scheme as well. So the other thing is that this water is fresh to brackish, and I'll try and finish on a slide to show how important it is to have actually water of lower salinity. If you're going to try and get water of high quality, and you want to use desalination, it's really, really important to start with water of higher quality as possible, because the amount of energy that is required to desalinate salty water is very, very high. So this is why, even if it doesn't pass the drinking water standards, if it's actually brackish or slightly saline, it can be polished and used for a number of things. So the ones that are here is obviously the South Down magnetite mine. There's the possibility of intensive animal industries, particularly piggeries and chickens and things like that. So Richard George and others, Adam Lillycrap will be talking about that tomorrow. Horticulture and the possibility of, in fact, I think there are some already uses of this for perennial pastures. So this is a summary of what is known of the aquifer, particularly the Whirlup Formation. The aquifer is a small component of the Whirlup Formation, of course, as we'll see in a minute. Its age, so it's got the age there, so it's quite very old, you know, and this is from Geoscience Australia as to what they've dated the age as, between somewhere about 40 and 50 million years, so it's the middle of the Eocene. It's up to 49 metres thick. There's this, and I'll talk a little bit more about this different components of it. It's quite deep, as I said, 30 to 140 metres below the ground surface, so that the channels are actually, particularly around where we are at the moment in the Albany area, the channels are below the existing sea level, so they're quite deep. Hydraulic properties, they're shallow alluvial to shallow marine sands, and deep channels is the main aquifer, and we've heard that several times. There are some cross sections, but I won't have time to show them. They're where the channels can be in two levels, so there can be an upper and a lower aquifer in the Whirlup. The recharge. This is an area where I think also more work probably needs to be done, but just from looking at the hydrographs and the salinity, it's clear that it is recharged vertically, probably from the Paleochannel, so the seepage coming down from the Paleochannel into the Whirlup. If you've got the hydrographs responding similarly and you've got the salinities very similar, then it's almost certainly going to be a vertical distribution of processes happening there. The other thing is, and Phil's already mentioned, the inland and particularly the lower rainfall areas have got the much higher saline salinity. The discharge, now this is interesting because it's deep, most aquifers have associated what we call groundwater dependent ecosystems. So these are lakes and phreatophytes, plants that actually can access the aquifer. So if you lower the water table in those in those areas, then you can actually get impacts on groundwater dependent ecosystems. As far as I'm aware, I'm happy to be corrected. The only one that I'm aware of is that the lower Marble-up area around Alaka and that. There's concern that the Water Corporation and DEWA have to make sure that the pressures there aren't decreased so much that there is an interaction in that area. The discharge, as I say, it's offshore, so there is a submarine groundwater discharge. So somewhere offshore, this system is discharging, as most groundwater systems that are on the coast do. And as I understand it, there's no one really looked at that submarine groundwater discharge in this area. This is a very quick introduction to stratigraphy, but how did that sand infill the channels? So here we've got the sea level quite low, high energy material coming down here. We've got sand deposited. As you go further out, you might get some clay and silt, and in the deeper area you might get some calcrete. As the sea levels rise, you can see the sand is now moving up the sequence. So if you have a sand in the bottom of a channel, it's not that it was all laid down at the same time. You can actually have the same sand, or a sand that looks similar, being laid down over a long geological time. And that's what we think here. So as you go up and up here, you can see the sand's now being deposited here, but here it's actually being confined to by what's underneath it. This is a type cross-section. There's a very classic paper that's been written by Clark et al. In 2003 of what is the sequence for the what's called the Plantagenet Beds. So there's a Paleochannel formation, the Whirlup formation. Both of them are coarser at the bottom and fine upwards. So when we're talking about the aquifers, we're looking about this little small part at the bottom here. So this gets finer and finer, and there's lignite, and as Phil described at the top of this. In fact, that was prospective for a while. People were interested, BHP I think did a lot of drilling around on the south coast to see if there were prospective coal deposits associated with that. I won't mention what these other systems are not existing in this area anyway. They're found further east. So what I'll do now is step through and show a few slides, 2 or 3 slides for each of these paleochannels to give you an idea of what is known. We'll start here in the what's called the King River Paleochannel. So this is the one that provides drinking water to Albany. And as Phil mentioned, this is the King River. It's probably a bit misnamed actually. It cuts right across the King River, so it's not parallel to the King River. Clearly, it cuts right across it at right angles and comes out onto the National Park of Torndurup here, and also out near the prison and the wind farm. There has been some mapping of the lower Whirlup, which is the Whirlup Sands component, and this is a report that Cheryl Ryan and others have written about 4 or 5 years ago now. And this is showing its existence as where the channel comes out. It's quite amazing that it actually follows the existing Torndurup National Park, or Torndurup Peninsula. And these numbers you can see here are its thickness, so how thick it is. So it's not very thick, it's up to 15 or 20 metres thick. It's in that area. And bear with me, I'm not going to go through what all these boxes are, but the thing is that the Whirlup Sand is this light brown here, and you can see here in this part, it's being accessed by a bore, and above that is what they call a middle sand, and above that is some superficial sands and limestones. So the lower Whirlup Sand is not the only aquifer for the Albany wellfield. It's actually a combination of 3 different formations, and in this area where they're pumping from, where they're modelling the pumping from, it's unconfined, but quite often it does have this confining layer above it. So it's quite complicated. The Department of Water and Environmental Regulation have different licensed amounts for this aquifer and that aquifer. So the Water Corporation are constrained by how much they can pump from those different aquifers, and they've got an allocation limit for each of them. This was actually the way that they've modelled it. So this is not what it looks like. But if you put it, it's a very simplified version to show how each of the different units interact. Okay, so there's a classic study that was done by Cheryl, Ryan and others, Jahit Yasertner and a few others. I think Andrew Morn was involved as well. So they've written a report which is available on how they identified the paleochannels in the area in the Albany hinterland. And what they did was they put up a plane, a Questem airborne EM, electromagnetics. So this is actually measuring where there's low conductivity. And low conductivity can be associated with several things, but one of the things is that if you've got sands with fresh water in them, it comes up as low conductivity. But if you have shallow rock, it also comes up as low conductivity. So you have to try and do drilling and do other things to try and identify what it is. But if you have high conductivity, it's generally you've got either salt or you've got a lot of clay. So it's a really good way of identifying what's under the ground. So this is what, and I'm afraid this is a very poor scale, but you can see these what look like channels coming up. So this is the King River channel going up that they were able to define by using the airborne geophysics. You can also see one coming up the Calvin River here, but this is possibly associated with shallow rock rather than a paleochannel. And you can see another one out here. There's a couple of out that way, which are associated with one near Nannerup, a very small one, and another one near Many Peaks. So this is a typical cross-section you'd get. So you're looking at areas where, see there's no red, here's a lot of red. You're thinking, well, here this must be clay here. This looks like it could be prospective. Let's do some drilling there. So it actually helps you target your drilling by making sure you don't go out and drill an area that's got a lot of clay or a lot of salt associated with it. And this is the map that Cheryl and others produced, and this is the King River Paleochannel. It goes up past the airport. They didn't, it obviously extends. You've seen that other map that shows it extends out here onto the Torndirrup Peninsula. But it goes up past the airport and right the way up, and there's a bifurcation up here. And some of these cross-sections that I'll show in a minute, they've actually drilled, so they've been able to prove up what the aquifers and looked at the salinity of them. So they've got one here at Nannerup and one over here at Many Peaks as well. So this is a couple of the cross sections. This is the main one, the King River, and you can see a series of bores. And the blue area here is the most prospective area where they've got an aquifer. It's so permeable, but it's also got water of 500 to 1,000 milligrams per litre. So that is inland from the Albany bore fields at the moment. So it is actually indicating that the Paleochannel does have some high quality water associated as you go inland. But I have to say it drops off quite quickly. So you don't go very far inland, 10 to 20 kilometres inland, and you've suddenly got water that's more brackish or mildly saline. And this is the other one, the Many Peaks, a very short, this is not the same as the Many Peaks I'll be talking about in a minute, but this is a very short one, and you can see that there is also some pressure water associated, 500 to 1,500 milligrams per litre, but it increases, the salinity increases in this one as you go deeper. The other thing, just before I leave it, there's some very, very good records that have been provided by Rockwater, and I'll be talking to them a little bit later on in another series, but this is what's happening to the groundwater levels in the area around the airport since about 1994, and you can see that they're fairly consistent, but there's a bit of an indication on some of them that actually we're now starting to get a bit of a tailing off in the levels, and for this one here you can see it's going down as well. And certainly the work that the Department of Water and Environmental Regulation did for the modelling that they did for the Albany well field, they took into account climate change, because this area has probably been cleared for long enough that the aquifer systems have now got, probably, this is my interpretation, they've probably got equilibrium with the current climate. So if the current climate has been drying, as Bryson's been telling us, then they're starting perhaps to have a little bit of a climate change signal associated with them if they've got a new equilibrium. I'll now talk about the Many Peaks one. So this is the one we were very, very close to when we stopped at the Many Peaks Hall. And so, as I mentioned, and we'll just go to the next one. This is a slide that Rockwater have provided for me. It's not in the public domain yet, but I believe it is going to be at some stage. So there's a major paleochannel. Perhaps I should orientate yourself. This is the South Coast Highway. This is Bluff Creek Road. This is Pfeiffer Road. So there's a major buried river channel, if you like, that goes that presumably was flowing from west to east, and there's a tributary that comes up from the south. I have no detailed knowledge of what's in this area, but I believe it's about 2,000 to 5,000 milligrams per litre at the most, so it's quite brackish, but it's good if you're going to do desalination, as I'll show later on. It's actually very prospective water for producing high quality water if you wanted to, if you start at lower salinities. So this is an area that is obviously being investigated for as a possibility for water supply for the South Down mine. Now, looking at the Wellstead paleochannels, we've got several. So that then again, they're flowing from looks like they used to flow anyway, particularly from west to east. We've got one that comes down from the north, one that comes from, as Phil mentioned earlier on, that one that goes all the way back to the lake systems, and there's another shorter one here that's in the south. And remember, the rule of thumb is that the further you go south in the higher rainfall, the better quality water. I think this is the case here too. So this is just a couple of the maps. This is from a report that Rockwater wrote, and it's actually in the public domain. It's actually associated with the report that went to the EPA. So there's some really great work that's been done in terms of defining. The Northern Paleochannel hasn't been defined that well, I presume because it had poorer quality water. There's a central paleochannel that goes through here. Sorry, I should mention, this bendy line here is the South Coast Highway, so you probably know it from where it bends and things like that. And then there's a southern paleochannel that comes through here, but you can see that it's been relatively well investigated, but I don't think it's actually the one that's most of interest at the moment as far as the mining interests are going. But there may be other possibilities of using the water in those paleochannels. The interesting thing is, what is the relationship between the two aquifers? And we had a bit of debate on the bus yesterday. If you look at the hydrographs for the two aquifers, and you can see the green and the purple aquifer, they're actually pretty well in sync. So it shows that there is a correlation. They're correlated, which means they're probably two things. One is one's influencing the other, or they're both responding to the rainfall in almost identical form. So there is as I said before, a likelihood that the recharge to the Whirlup is caused by seepage from the Paleochannel. So that there's the two reasons for that are that they do have this correlation between them. In some cases, they're very, very highly correlated over a long period of time. But the salinities are very similar as well in many cases. Obviously, there are cases where the deeper Whirlup particularly has got a higher salinity, and it's not related to the overlying Paleochannel. But I wanted to put this one up because I thought was interesting, because this is actually showing 8, 9, 10, 11 metres below sea level, below the surface. So you can see that you feel very confident back here that 12 metres, you've got a huge amount of freeboard. There's not going to be a salt problem in this area, and particularly if you're monitoring over here. But 2017, you can see that this is the rainfall here was particularly high, and it actually jumped up 2 metres, the levels in that period. And Sylvia probably knows 2017. I think you wrote one of your reports, you said you couldn't get out and monitor the bores because it was just far too wet. But the fascinating thing is, if you looked at that graph or that table that Bryson put up, Cranbrook was having one of its record dry years. So there's something about being very coastal. There's something very coastal about it. But anyway, it could be that these wet years are very important. And this is the response to the last year's wet year. So this is showing the importance of wet years. And if we can understand the recharge mechanisms and how important it is to perhaps stop this water finding a way down into the aquifer, would be very, very important. What does the sand look like? This is again from the another Rockwater report in 2017. So we talk about this deep channel, and here's a profile of what it looks like. It's not one channel. Quite often it's quite a complicated one. And the prospective sands are not in one area. They can be spread over this area, and even in the subsite, the channels to the side, there can be some sand. So it's not a very simplistic system. But obviously the deeper the area, the more sand there is, the more likelihood you are of getting a good yield. But at the same time, sometimes if you chase yield, you lose water quality. So it's a bit of a trade-off. I like this particular production from the Rockwater 2017 because it actually shows you that long-term trends. Where are the groundwater levels rising and in which, 5 minutes, I will. And it's actually, if you look at those ones, a lot of the ones in the Paleochannel, they've been going up to 15 to 20 centimetres a year. So about every 5 years, we've got about a 1 metre rise. So it's still got a freeboard, but it's still going up. There's one bore in there that's been rising by 1.6 metres a year for a long period of time. So there's a recharge area, perhaps one of Phil's sinkholes associated with that. Okay, I'll just finish up on the last Paleochannel, which is up in the North Stirlings, because we don't want to forget the North Stirlings. This is part of the Albany Sandplain. And there's the Whirlup Plain up here is producing, there's got a couple of channels coming down. This has actually got quite good quality water up here. So it's actually brackish to mildly saline water in the Whirlup Plain, but as soon as you get down here into the North Stirling Basin, it becomes hypersaline, over 100,000 milligrams per litre. So they could be both water resources, if you think about it. This one for whoops, going back. This one for drinking or, for stock water, and this one here for producing salt products. They're one extreme to the other. I'll go through this very quickly. There's Steve Appleyard did some work, and it's all published on the web that shows the channel coming down from the Whirlup Plain. This is a 20-metre channel. It probably flowed out to the west. And then later work, when you looked at the salinity mapping and looked at the hydrographs, it's probably now flowing out to join the upper Paleochannel. So the upper Paleochannel rivers come around the northern side of the North Stirling's basin, starting to capture some of that old Paleochannel. I just wanted to leave this, and I'm sure that this is not the best figure, but this is why brackish water is so important. So here we've got the amount of energy required to take the salts out of water through using reverse osmosis, and here is what percentage of the salts you're removing. And these other coloured lines are how salty the water is. So this is 1 gram per litre, so it's 1,000 milligrams per litre, 3,000, 5,000, 10,000. Seawater's 35,000. So you can see how much energy you need to do to actually take salt out of water. So it's really, really important to be down here if you can get this low salinity water, and also to only take a certain percentage of the water out. The only problem with only taking a small amount of, the percentage of the salt out, if you go down here, you end up with a very large discharge brine. And that's one of the problems with seawater desalination or desalination of any water, is that you've got to get rid of the brines. So I think I've got the last slide, so I'll keep Joanna happy. The Whirlup Formation can contain fresh to brackish groundwater, moderately permeable but thin sand. So it's not very high yielding. As I say, if Perth was located here, we'd have major problems because we just don't get enough water into that system. The highest quality looks like it's Albany. I'm guessing Many Peaks is the next highest quality one, maybe Wellstead, and certainly the North Stirlings has got poorer quality water. The formation seems to be recharged by percolation from the Paleochannel overlying it. The mechanism is poorly understood. Extends well below sea level, so there's only there's only one area that I could come across where there's groundwater dependent ecosystems, but there's discharges probably offshore. It seems to be that airborne geophysics and drillings define some of the channels, but that plane-based airborne geophysics was not the best one at all. Helicopter-based geophysics would have been far, far better. So SkyTem, for instance, would have been really much better, would have been able to penetrate shallower and give us a much better idea of where they are. The quality of the water makes them prospective for use, particularly as we'll hear tomorrow from Richard George about solar desalination possibilities and using intensive agricultural industries. But I'll have to finish on a note. Having looked at and spent a lot of time looking at water supplies for Perth and that on the Perth Basin and the hills and everything like that, it's a very poor water quality area here, I'm sorry I have to say. Thank you very much.